Hello everyone, Assalamu alaikum. This is Tashik Ahmed, and in today's short lecture, we will learn about a simple circuit solving technique which is called superposition principle or superposition theorem. So, before moving into the main topic, at first we need to know about linearity and what are the properties of linearity. So, linearity simply refers to the linear relationship between the cause and effect or the input and output. It has two properties. One is homogeneity and another one is additivity. And an element which follows these two properties is called to be a linear element. So here we are saying that resistor is a linear element. Why? So if we look from the homogeneity perspective, homogeneity says that let's suppose we have a simple linear element and we are giving an input. As a result, we are getting a corresponding output. Now, according to homogeneity, if we multiply that input with a valid constant, then the output will be multiplied by that same constant as well. Now, how voltage and current across a resistor follows this rule? Let's see. We know from Ohm's law that V is equal to IR. If a current I1 is flowing through a resistor R, then the voltage V1 will be the multiplication of I1 and R. Now we can consider this I1 into R as a function of I, where I1 is the input and I1R is the corresponding output. Now if we multiply the input with a constant K, then eventually what we are getting is actually K into I1R. So eventually it says that if we multiply our input with a constant K, then actually we are getting the output as a multiplication of K and the previous output Fi1, right? So it is following the homogeneity property. Similarly, what additivity, let's suppose now we have multiple inputs, a lot of inputs, maybe 1, 2, 3, 4, 5, 6. Now, for each of the inputs, we have corresponding outputs, right? So according to additivity, if we sum all the inputs together and give it as a single input, then the output will be the summation of all the corresponding outputs. Let's suppose we have two currents, I1 and I2, and for two currents we have two voltages, V1 and V2. That means I1R into and I2R. We can consider them as two functions, f of I1 and f of I2. Now, if we sum up all the inputs, I1 and I2, and give it as a single input like this, f of I1 plus I2, then we will get I1 plus I2 into R, and if we break it down, we are getting that I1 into R plus I2 into R. So, actually, what are we getting? We are getting the sum of my individual outputs as the whole output, right? So, yeah, this is how the voltage and current actually, the voltage current relationship actually follows the linearity. Now, what about power? We have already seen that the resistor is a linear element and voltage and currents are linear quantity. Now, what about power? So basically, power is not a linear quantity because what we know is equal to P is equal to V multiplied by I. Here we are combining two linear quantities in a non-linear way. So we are introducing the non-linearity here. And also, if we look into it from the homogeneity and additivity perspective, we can see that P is equal to I square R or V square by R, we can say. If we consider that as a function of I or V, here we are considering as a function of I, right? So if I is the input, and when we are putting I in the function, we are getting the output. So f of I is the output. Now, if we multiply the input with a constant K, the output is actually K square into the f of I, right? So we are multiplying the input by K, but we are multiplying the output by K square. So it doesn't follow the homogeneity property here. Also, if we look into for the additivity property, here we can see that when we are giving the input, the summation of the inputs as a single input, we are actually not only getting the summation of outputs as a whole output, but there is another extra term which is 2 into I1 and I2. So it doesn't follow the additivity test as well. Hence, we can say that power is not a linear quantity. Now, the superposition principle only works for linear elements. We can only find out the linear quantity by using this formula. That means we can find out the voltage across or the current through a resistor or a branch in a circuit by using this formula. And superposition principle says the voltage across or current through an element in a linear circuit is the sum of the voltage across or the current through that element due to each independent source acting alone. Here are keywords to highlight: independent source and acting alone. That means in my circuit there can be dependent sources as well. But when we are applying superposition theorem, we will only consider the independent sources and we will consider a single source at a time. There can be numerous sources, 5, 4, 6, but we will consider only a single uh, independent source at a time, and we will calculate the voltage, corresponding voltage or current for that one independent source, and at the end we will sum up all the voltages or currents together to get our total current or voltage, like this. Let's suppose we have a circuit like this where we have two sources V and I, and there are only one resistor, and across that resistor we have a voltage V naught. Now when we will apply superposition principle, we will only consider a single source at once. So at a time we actually turned off the current source first, and then again we turned off the voltage source. And for each of the sources, we are getting the corresponding voltages across the resistor. One is V naught prime and another is V naught double prime. And by adding it, by summing it up, we are actually getting our V naught. These are the basic stuffs. 0 volt means short circuit, 0 ampere means open circuits. So it's a basic. Now we will go through a stepwise example. Let's suppose we have a circuit here. We have two sources, independent sources, and we need to find out the voltage across this 7 ohm resistor. So what we are saying that for each of the, let's suppose for each of the single independent sources, the voltages are V naught prime and V naught double prime. So we need to first calculate these two entities. Then we can sum these two quantities. We will get the V naught. The step one is we need to turn off all the independent sources except one. So let's turn off the current source first. When we turn off the current source, what we get? We actually get a open circuit. So this is an open connection. So this is a single loop, and from this circuit we can see we can use a simple in step 2 we need to find out the V naught. So we actually use a simple technique like the voltage divider technique here, and by using the voltage divider technique we actually found out this V naught. This will be actually a V naught prime. Okay, I missed the prime here. So V naught prime will be equals to what? By using voltage division rule, we are getting V naught prime is actually 5.6 volt. This is actually the corresponding voltage for the independent voltage source because we turned off the current source here. Okay. Now we will repeat step 1 and step 2 for each of the independent sources. Here we have done it for the voltage source. In the next step, we will do it for the current source. Now we turned off the voltage source, so it will be a short circuit. Now here at this node, the current is dividing into two currents, I1 and I2, and this I2 current is flowing through this 7 ohm resistor. So yes, if we use current divider rule and find out the value of I2, then we can easily evaluate the value of V naught double prime here. So we have done this. We calculated I2 first by using current divider rule. We all know this is a very basic rule. We have learned it at the very beginning. So we got 0.6 ampere. Then we evaluated the value of V naught double prime. So now we have both the values V naught prime and V naught double prime here. So we will sum it together, and what? We got our V naught, the total voltage. So that's how superposition principle works. And we can only use it to find out the linear elements, linear quantity like voltage or current. We cannot calculate power using this superposition principle, because superposition principle is based on the linearity properties, right? And we have seen that power is not a linear quantity. So we cannot calculate power using superposition principles. We can only calculate voltage and current through or across a resistor or a branch using superposition principle. Thank you. This is all. And yes, an example involving dependent sources will be shown in the next video. Thank you so much.